C is becoming a very universal language these days. 2 or 3 years from now, do you see C replacing assembly and VHDL completely? What is your view?
No, I don't think so. I mean, as I've spoken this morning, there are very different domains, different applications areas that are using these things. So certainly not replacing VHDL and Verilog. I mean, Verilog is now becoming, or rather System Verilog, much more of an accepted standard here. We did a verification survey a couple of years ago now, the last time that one was run, and that showed that actually India was leading in terms of percentage respondents, the adoption of System Verilog. So I mean, that world is still not necessarily in its infancy, but still, very much a long way to go there still. The two communities will coexist for a long time to come, and tools will exist that enable the two to coexist for the foreseeable future, I think.
Good. Apart from the programming language, what are the software engineering changes happening in both VLSI and embedded?
Software engineering. Well, I mean, nowadays
the mega changes.
Yeah, I mean, all about multi-core stuff. That's where you see a lot of stuff nowadays. From the EDA perspective, though, this interesting change that we see is the way that we're facilitating the two software and hardware worlds to coexist more now. We spoke a lot this morning in the keynote about co-design, co-verification, but in the future, we're looking at solutions that allow people to remain much more in their favorite IDE, with their compilers, debuggers, and basically drill into the hardware domain of the world.
So what's the role of open source going to be playing in the coming years?
Yeah, it's an important thing. It's something that Mentor are very much involved in the software world, and definitely playing an increasing part in the world.
And in the EDA industry, it uses Synopsys, Mentor, and other player, Cadence having a huge share.
Right.
Do you still see some small players in the industry having some role to play in the coming years? It's going to consolidate further.
I'm not sure that, there will, consolidation's inevitable, I think, in EDA as it is in semiconductors and other industries. To what extent that will reshape the landscape now is not clear, because if you look at the way things have gone now, you have Mentor, Cadence, Synopsys are really the big players, and now with Magma having disappeared, there's a very large gap now down to much smaller players now. So it's an ongoing thing. There'll always be acquisitions of smart new technologies, but those kind of things won't reshape the whole landscape of the industry in the future now, I don't think.
In chip design, how much does the software help in adding product differentiators? Like, generally in analog they try to play around with the process, with the fab and all. But how much they really do those product differentiating features, add product differentiating features using advanced software?
Yeah, well, I think it's huge. I mean, software is amongst the smart chip designers create these fantastic SoCs, but at the end of the day, if you look at some of the modern apps, and we saw the example spoken about this morning in the keynote, the iPhone and the tablet type devices, the differentiation is huge in the software applications that are there. I mean, a phone is a phone, but one of the things that really differentiates some of the smartphones now is the fact that there are tens, hundreds of thousands of apps available for them.
These days fabless has become very popular. The fabless guys don't have direct access to the fab. They can do much in the software only.
Right.
So in that sense, the fabless they can still compete with the fab companies in defining good product features.
Absolutely. Yeah. I mean, all of the companies we've met this week have invested hugely in software. I mean, it's clear if you just go visit some of the large fabless companies here in India. Massive software teams compared to the hardware.
So they're not really kind of a limited or a handicapped kind of a thing without...
Oh, I don't think so. No. I mean, if you've got the software folks there, and a huge part of the differentiation of products is in that space, there's no doubt.
Particularly in analog domain, analog and mixed signal, if not in digital. That's my question, very particular to analog.
Yeah, I mean, again, as we spoke about earlier, analog's a very special place. Some of the analog functions have been absorbed into the digital part of chips nowadays, but there's They're still emerging, or not necessarily emerging, but important analog functions, MEMS, all sorts of things that have been around for years, but are playing an increasingly important role in success of modern designs.
These days, third-party IP is largely used. Do you see the current trend of third-party IP use to grow further next few years?
Oh, absolutely. I mean, you look at modern chip sizes, billions of devices. It's an understood fact that no one designs those from the bottom up now. Most designs nowadays are either a derivative of a previous generation or a chip involving a lot of new IP. It's going to be the way to go, and IP will start to take different forms and shapes and just become more and more complex in the future.
But still there are issues like, the approvals and the reliability of the IP, those kind of things. So are they still people are a little scared about using third-party IP, or they're quite open?
I think people, you just have to look at the way the market's growing. I think people accept it. It's inevitable. There'll be issues depending on the source of the IP, but a lot of the vendors nowadays are very reliable. The IP is well tested, and you have some emerging standards.
That's the thing. Well tested, not well tested. There are IPs which are well tested.
It's obviously a mixed bag depending on who you look at. A lot of the IP nowadays, though, is very well verified. Comes with, verification suite along with it, and we have, emerging standards around tests that allow IP to be brought together and tested effectively to make sure these subsystems work.
I'm asking, there's a lot of Indian companies in this business.
Yeah, absolutely.
With Asia, particularly China and India, going full speed in chip design, do you see, they're on par with the European years in the complete product design, if not?
It's interesting, and I thought about that this week whilst I was here, because a few people were asking me how I saw India evolving in design and how, competitive and what have you. And I think, we all need, and yourselves included, need to stop kind of thinking of India now as some kind of secondary design region. If you look at the companies that are here, it's not a fact that they're now, just designing blocks for some parent company based somewhere else. The companies I visited this week have got hundreds of place and route chip designers designing smart products. It's no longer the case that India is kind of, any less on par than other regions now. There are great designers here, and some of the products are pretty impressive.
Very good. My other two questions is, it's about FPGA and the video complexity. In the FPGA domain, do you see the more role of a programmable hardware coming into the picture, even in the a bit of programmable hardware, even into the mainstream SoC?
Yeah, well, it is. You look at FPGA devices now, they're amongst the leading edge in using the latest technologies. The capacity of those devices is huge. So, yeah, they play an absolute critical role in product design nowadays.
As FPGA, yes, they are playing critical role. What about even normal SoCs from Broadcom or Qualcomm, or like that, putting a bit of programmable hardware inside that, so that they can use later?
Yeah, you see that programmable hardware on a chip. There's some concepts of those sort of things going around, and those companies are clearly using these. Capacity for real leading edge devices used to be an issue, but not the case now. These things are huge devices, perfectly capable of competing with SoCs effectively.
Cool. If you look at the present level of processing, what's happening in Pentium processing, it's more of a data crunching. And if you look at the future, it's more of an audio, video kind of a data. So the huge media streaming, whatever, high definition.
Right.
So the present chips, I'm sure you're aware, they're not really capable of. So if you look at the future, like 5-6 years, totally going to be video, audio kind of a thing. In that sense, how you see the future chips going to be? It's going to be 3D.